Hi, hello, welcome back, students of class 11. In this video, you are going to see numerical problems related to distance covered, displacement, average speed, and average velocity. These are the four concepts. Regarding those concepts, we are going to see few numerical problems. I have taken this from the book S.L. Arora. If you have this book, you can continue with the practice and how the concept is we are going to see. Now, without wasting our time, let us get into the concept. Before starting this one, we need to learn few formulas. So for distance, there is no direct formula. For displacement also, there is no direct formula. Well, coming to speed, speed is equal to distance by time. Velocity is equal to displacement by time. And average speed, SAVG, is equal to total distance by total time. And average velocity, what you have studied, final position minus initial position x2 minus x1 upon final time t2 minus t1. And according to the situations, let us try to see different formulas and numerical problems. So first numerical problem, in the figure 3.12, a particle moving along a circular path of radius r. For example, this is one circular path with the radius r. It starts from a point A. Consider this is a starting point, starting, and moves anti-clockwise. This is anti-clockwise. Find the distance traveled with the particle as it moves from A to B. So first we need to find distance where it is moving from A to B. Then moves from A to C. Second condition he is giving, if it is moving from A to C, what is the distance? Third, moves from A to D. A to D. Number 4, complete one revolution. Complete one revolution. Okay, let us try to find the distances. Also find the magnitude of displacement in each case. Okay, our duty is to find distance and displacement both. Okay, first A to B. Anyhow, this is a circular track. We know one complete circle is nothing but one circumference of the circle. Circumference of the circle is given with the formula 2 pi r. So distance or circumference is 2 pi r, that you have to understand. Now distance A to B. A to B in the sense this is only 1 by 4th of the circle. So 1 by 4 into 2 pi r you can do. 2 ones, 2 twos. So answer will be 1 by 2 pi r is the total distance traveled by the body. Now, if they ask displacement, displacement is, that is the shortest distance, or simply to say, it is a straight line drawn from initial point to final point. A is the initial point, B is the final point. So you can draw a straight line. Now it becomes right angle triangle. You need to find out this distance r, or you can find out this distance d. We know this value is r. If this is radius, this is also radius, this is also r. Here it is r, here it is r. We have to find d value. So that is, or else you can keep it as hypotenuse only. We know hypotenuse square is equal to opposite square plus adjacent square. Opposite square, let us mention it as x if required. X square is equal to opposite is r square plus this adjacent is also r square. It becomes x is equal to, send that square that side, it becomes root of r square plus r square, that is equal to root of, there are two r squares, so that 2r square. Now r square, if it is coming out, it becomes r. 2 will be as usual, that is root 2. So displacement s is equal to r root 2, or you can go with root 2r. Both are correct. Next, from A to C is asking, okay, it is starting from A and it is going to C. So it has completed half of the circle. So half into circumference of the circle is 2 pi r, 2 gets cancelled, and left is pi r. Distance is equal to pi into r when it is moving from A to C. Now what is the displacement? Displacement is nothing but straight line from initial point to final point. A is the initial point, C is the final point. Draw one straight line. From here to center of the circle, it is r. Again, from center of circle to circumference of the circle, it is r. So displacement will be r plus r, which is nothing but 2r. So this is distance. Pi r is the distance. Displacement is equal to 2r in the case when particle is moving from A to C. Okay, now A to D. we should find distance D is equal to, this is A and it is coming to D. Total it has taken 3 by 4th part of the circle. So 3 by 4 multiplied with circumference of the circle, that is 2 pi r, 2 ones, 2 twos. So answer will be 3 pi r upon 2, that is distance. When particle is covering 3 by 4th of the circle, displacement is equal to same. This is initial point, this is final point in the condition. Draw one straight line. Now you should find out this hypotenuse, which x value. Now this is adjacent, it is opposite, however you want you can take it. Now this value is r, this value is r. Same how you have solved this one, same like that you are going to solve it here, and it becomes r root 2 or root 2r, both are correct displacement. Now one complete revolution or one complete circle. For a complete circle, straight away you can take distance as 2 into pi into r. While coming to displacement, it is 0, because if initial point and final point, if both points are same, then displacement value is 0, because you can't draw any straight line. Like that you need to take answers for this. Next, second example from the chapter motion in a straight line. Here this numerical problem is related to distance and displacements, which is taken from the NCERT textbook. A car is moving along x-axis. Okay, only x-axis. This is origin O and it is moving towards x-axis as shown in the figure. It moves 0 to P or O to P. This is O and this is P value. First it is moving O to P. That is the condition what he is giving. In 18 seconds, O to P in 18 seconds, and returns from P to Q. Second condition, it is returning from P to Q in 6 seconds. Time is 6 seconds. What are the average velocities and average speeds of the car going from O to P and from O to P and back to Q? Okay, fine. Let us see all these. So first they are asking, what are the average velocities and average speeds of the car going from? First, let us try to find O to P in this condition. Now, average speed. First, let us go with average speed. Average speed, we know it is total distance by total time. Now, what is the total distance from O to P? This is O to P. Total distance is 360 meter upon what is the total time taken O to P, that is 18 seconds. 360 upon 18, 18 ones, 18 twos, 36. So answer will be average speed SAVG is equal to 20 meter per second, that is a SI unit. Now let us try to find average velocity also. VAVG, average velocity, is displacement by time. Means final point x2 minus x1 by t2 minus t1 also you can take. Now what is the final point? P. So P is the final position. X1 is O is the initial position upon T2. T2 is final time, T1 is initial time. So at P value is 360 minus 0 upon T2. How much time it has taken? So here it is 0. Time is 0. At O, time is 0. Here, time is 18 seconds. So 18 minus 0. It becomes same 360 upon 18. 18 ones, 18 to 0. So VAVG value is also 20 meter per second. Like that, we should solve it. Then what is the next condition? O to P and back to Q. So body is moving from O to P. Again, it is moving back to Q. Now we have to find out average speed and average velocity. Okay. SAVG, average speed is equal to, we know formula, total distance traveled by the body upon total time taken. Now what is the total distance? Total distance is OP, first it is moving and then it is coming back from P to Q, OP plus PQ upon time taken from O to P plus time taken from P to Q. That is equal to, from O to P, distance is 360 plus from P to Q. You see, from 360, it is going back to 240. So how to take 360 minus 240? It becomes 0, 6 minus 4 is 2, 3 minus 2 is 1, 120. Upon, now, you see from here to here, it has taken 18 seconds. Plus, again, from here, P, here to here. So it is 18 minus 12. It has taken 6 seconds. That is equal to 360 plus 120. How much you can take? See, 360 plus 120, it is 480. In numerator, we'll get 480 upon 18 plus 6. It is 24. Here, 24 ones, 24 twos. Right? So 0. Now, yes, AVG value is equal to 20 meter per second. Now, what is VAVG in the second condition? VAVG same. X2 minus X1 upon T2 minus T1. Now, what is the, now body, it has started at O, it went to P, again came to Q. Now, what is the final point? Q is the final point in this condition. Q minus, what is the initial point? O. O upon, now time taken T2 minus T. Now that is equal to our total time, how you can take it. Now final point is 240. Q is 240 minus 0 upon. Now T2 minus T1, or if you get confused, what you can do? From here to here, how much time is taken? 18 seconds. Again, it is coming back here, 6 seconds. Same what you can take here, 18 seconds plus 6 seconds. So here it is total displacement. Numerator is total displacement. Denominator total time. Now that is equal to 240 minus 0, 240 upon 18 plus 26, that is 24. 18 plus 6, 24. Tens. So VAVG value is equal to 10 meter per second. Like that you need to calculate. This is the answer for this question. Moving to the next topic. It is related to average speed and average velocity. This let us try to find it out. And the question is, a body travels from A to B at 40 meter per second and B to A at 60 meter per second. Calculate average speed and average velocity. Okay, the condition here you see, this is A and B. They are not talking about distance. So distance, they are not talking about, only speed. So A to B it is going with speed 40 meter per second. And B to A, it is going with the speed 60 meter per second. So in this condition, what is average speed? Yes, AVG. We know formula, na? If a body is moving with some velocity and coming with some velocity, and if distances are same, then formula will be 2 V1 V2 upon V1 plus V2. So straight away you can substitute 2 V1 value is 40. This is first velocity V1. This is V2. 40 multiplied with 60 upon 40 plus 60. That is equal to 46 fours 24, 24 into 2 or 2 into 6 fours 24 00 upon 60 plus 40, that is 100. Now 2 zeros gets cancelled. 24 multiplied with 2, that is 48. Yes, AVG value is equal to 48 meter per second. Now they are asking VAVG. So what is velocity, average velocity? Displacement by time. If a starting point is A, it is moving forward and coming backward. Ending point is also A. Starting point, ending point, if both are same, then it is 0. 0 by anything is 0. That is 0 meter per second. Right. So it is, there is no meter per second. It is answer 0. Next, fourth example. On a 60 kilometer track, okay, there is a track. Consider this is starting point, O origin. This is ending point, something like A. Distance, they have given D is equal to 60 kilometer. Train travels first 30 kilometer with uniform speed 30 kilometer per hour. Okay, this is half of the distance. This they are talking about D1. D1 is equal to 30 kilometer. So first 30 kilometer with the speed of 30 kilometer per hour. How fast must the train travels next 30 kilometer? So this distance 2 is equal to 30 kilometer, and they are telling this is V1 or speed 1, and with how much speed train should travel means V2 is equal to question mark, so that SAVG average speed is 40 kilometer per hour. So we need to find out this V2. How to make it? We know formula. SAVG is equal to 2 V1 V2 by V1 plus V2. Now they give this value SAVG. What is that? Is 40. 40 is equal to 2 into V1 value is 30 multiplied with V2 value we don't know. Let us mention it as V2 only upon V1 plus V2. V1 is 30 plus V2 we don't know V2. Now send this 30 plus V2 this side. Get this 40 here. It becomes 2 into 30 multiplied with V2 upon 40, which is nothing but 30 plus V2. 2 ones, 2 20s. Now it becomes that's it, right? Then 30 plus V2 is equal to 30 by 20 V2. 0, 0 gets cancelled. Now V2 is equal to send this 30 that side. It becomes, or else what we can do is keep this 30 this side, send that V2 that side. So 30 will be this side, 3 by 2 V2. If you send that plus V2 this side, it becomes minus V2. Now 30 is equal to, you can take V2 common. If you take V2 common, it becomes 3 by 2 minus 1. 3 by 2 minus 1. 30 is equal to V2. 3 by 2 minus 1 is 3 minus 2 by 2, which is nothing but 1 by 2. This value is 1 by 2. Now this can be written as 30 is equal to, this V2 will be here. This 1 by 2, if you send that side, it becomes 2. Right. So V2 is equal to 30 multiplied with 2. That is 60 kilometer per hour. That is the value. V2 is equal to 30 kilometer per hour. Like this, you need to solve this. Okay. Next we have a body covers 1/3 of its journey with speed U. Next 1/3 with V. Last 1/3 with W. Calculate the average speed. See, all distances are same and all speeds are also same. I mean, U, V, W speeds are different, but distances are same. There is a path. For example, if D1 is equal to D2, this D1 is equal to D2, then average speed it will be SAVG is equal to 2 V1 V2 upon V1 plus V2. Now the condition, there is a path where 3 parts are there. This D1 which is equal to D2 which is equal to D3. So all these 3 paths are same. Then if it is traveling with different velocities like U, V, W, then it will be SAVG is equal to 2. It is 3 because 3 parts are the 3. What are the velocities you need to multiply? U, V, W upon UV plus VW plus UW or WU. This is the direct formula what you can write the answer here. Next, example 6. A body traveling along straight line traversed 1/2 of the total distance with velocity V0. The remaining part of the distance was covered with velocity V1 for half time and with velocity V2 for the other half time. Okay, graphically how we can mention. Okay, this is the point A. Let us consider it is traveling and it is reaching point B. What they are talking, it is going in a straight line. 1/2 of the total distance with velocity V0. So this is 1/2. This is half of the distance with velocity v naught. The remaining part of the distance was covered with velocity v1 for the half time. Here, this is the remaining part where this half part is covered with velocity v1 and another part with v2. This part with v2, another half time. Find the mean velocity averaged over the whole time of the motion. Okay, now our duty is to calculate total velocity, average velocity we need to find out. Okay, how to find out average velocity? Now from A to B, do we have any distance? No. So let us take the distance as x. Now this half of the distance it traveled with some time. Let us take it as t1. And remaining half total distance, let us take it as t2. That is the total time. T1 is the total time taken to cover half of the distance and T2 is the time taken to cover remaining half of the distance. Again, here again there is half. So it will be T2 by 2. This one also it will be T2 by 2. Don't get confused. Okay, T2 by 2, T2 by 2. Now, so what is T1? T1 value we know. We know speed is equal to distance by time. From this, time is equal to distance by speed. Now, what is the distance here? Half of the distance. Right. So let us consider total distance as x. Then half of the distance it becomes x by 2. Now in place of distance you can mention it as x by 2 by what is the speed of the body? It is v naught. V naught. So t1 is nothing but set the 2 to denominator, it becomes x by 2 v naught. This is the t1 value we got at present. Now another half of the distance, this is x by 2, right? Now time is t2. Now if you want to find t2, you see speed is equal to distance by time. Distance is equal to speed into time, because here we have two speeds now. So speed into time. Let us take what is the distance? X by 2. Instead of this distance we have mentioned x by 2 is equal to what is the speed? Here it is going speed v1 at t by 2, v2 t by 2. So total we need to add, isn't it? So it becomes speed is v1 multiplied with time will be t2 by 2. v1 multiplied with t2 by 2, that is half. This half. What about this half? Plus v2 time is t2 by 2, like this. So if you make everything together, it becomes x by 2 is equal to v1 t2 by 2 plus v2 t2 by 2. Again, if you further solve it, it becomes x by 2 is equal to LCM is 2 v1 t2 plus v2 t2. Again, if you further solve it, here 2 can be gets cancelled. X is equal to, if you take t2 common, it becomes v1 plus v2, right? v1 plus v2. From this, if you need only t2, then send this whole term this side, it becomes t2 is equal to x upon, because it is multiplying with t2, it becomes x upon v1 plus v2. Now here we got t1 value. t1 is equal to x by 2 v naught. t2 is equal to x by v1 plus v2. Now what is average velocity or average speed? Yes, avg is equal to total distance traveled by the body in total time taken. What is total distance? Distance 1 plus distance 2. What is total time? t1 plus t2. Now what is total distance? It is x by 2 plus x by 2. d1 is x by 2 only, right? Here. So this d1 is x by 2, d2 is x by 2, x by 2 plus x by 2. And time, t1 is equal to x by 2 v naught here. So let us mention upon t1 is x by 2 v naught plus t2 x by v1 plus v2. Now this we need to solve it. So if you try to solve this one, numerator x by 2 plus x by 2 is x upon. Now LCM is 2V naught multiplied with V1 plus V2. Here, this denominator, 2V naught multiplied with V1 plus V2. Then it becomes X into V1 plus V2 plus X into 2V naught. Now, that is equal to X upon. Now, in this 2, we have X as common. Take X common, it becomes V1 plus V2 plus 2V naught upon this denominator, 2V naught V1 plus V2. Now, here X gets cancelled. Total this term becomes reciprocal. It is equal to 2V naught V1 plus V2 upon V1 plus V2 plus 2V naught, which is nothing but SAVG, average speed. Like this, you need to solve this numerical problem. Now here you have 5 numerical problems, 5 to 6. You see these numerical problems and try to solve it. So you see this question, try to solve this first question. Of course, I'll solve the answer. You can pause the video or you can keep mobile aside after seeing the question. Solve it. Again, you can come back. Or you can pause this video right now, solve the question, and I'll solve the answer. You can cross-verify it. Okay, let us try to solve this first question. Okay, you can cross-verify your answer. Cyclist moving on a circular track of radius 100 meter. So there is a circular track of radius R is equal to 100 meter. Completes one revolution in 4 minutes. One revolution in 4 minutes. T is equal to 4 minutes. What is average speed? So yes, AVG is equal to, we know, total distance by total time taken. Total distance is equal to 1 round upon total time taken is 4 minutes. So what is 1 round? It is circumference of the circle, that is 2 into pi into r by 4 minutes. 4. That is equal to 2 into pi into r value is 100 upon 4. Here 2 ones, 2 twos, 2 ones, 2 fives, 10, 0. So answer yes, AVG is equal to 50 pi is there. 50 pi, we know SI unit is meter per second. So this is the answer. Now we should find VAVG. VAVG, of course, it is 0. Why? Because consider this is a starting point and this is the ending point. So starting and ending point both are same. So it is 0. Now plan for second one. You can pause this video and solve this second. After solving, you can come back. I hope you have solved it, but the answer is so simple, that is straight away this is the answer. Body travels first half distance with velocity v1, second half with velocity v2. Here they are not talking about the distance. Here the thing is both distance are same. t1 is equal to t2. When distances are same and speeds are different, then automatically you are going to take the formula 2 v1 v2 upon v1 plus v2. Okay, this third one, solve it and come back. Okay, now if you see, car covers first half of the distance between two places at speed 40 km per hour and second half is 60 km per hour. What is the average speed? So straight away here our mind, it has to go like two distances d1 is equal to d2, so that speeds are different. Now formula, yes, AVG is equal to 2 v1 v2 upon v1 plus v2, that is equal to 2 into v1 value is 40, which already I have solved in example problem. 40 multiplied with 60 upon 40 plus 60, that is nothing but 2 into 40 multiplied with 60 upon 40 plus 60, that is 100, that is equal to 2. 250 will be cancelled, that is equal to 6 4 24, 240 00 upon 50. So or else what you can do for the simple calculation, 2 into 40 into 60 upon 100. 0, 0, 0, 0 gets cancelled. 6 4s 24, 24 2s 48. Straight away you can write the answer 48. So for easy calculation. Now plan for this fourth. I think you have solved this fourth. Of course, answer is present here, but you should know the method of solving. Okay, fourth question. A train moves with speed 30 km per hour in the first 15 minutes, with another speed of 40 km per hour in next 15 minutes, and then with speed 60 km per hour in last 30 minutes. Calculate average speed. So there are three paths given. In first path, it is traveling with a speed 30 km per hour, kmph. In 15 minutes, time is equal to 15 minutes. Second, it is traveling 40 km per hour, kmph 40, and time is 15 minutes. And last path it is covering with a speed 60 kmph and in time 30 minutes. Now what is average speed they are asking? Yes, AVG is equal to total distance upon total time taken. What is total distance? Is there any distance? Here we don't have distance. But D1 is equal to D2 is equal to D3, and that is also there is no confirmation whether all these distances are same. What we can do, we can get the distance by using the formula speed is equal to distance by time, and distance is equal to speed into time. Now we need distance D1, D2, D3. Now for D1, what is the speed it is traveling? This is S1 speed, 30 multiplied with time 15 minutes. So 15 minutes upon 60. Why 15 upon 60? Because it is minutes, we have to convert to hour. D2 is equal to speed is 40, time 15 upon 60. Now D3 is equal to speed is 60 multiplied with time 30 upon 60. Now if you multiply and divide everything, you are going to get what? So here you see 31s, 32s, 2, 15. It is 7.5. Now 0, 0 gets cancelled, or what we can make is 15 4s 60, right? 15 4s 60, 4 ones, 4 tens. So here D2 is 10, D1 is 7.5, D3 31s, 32s, 2 ones, 2 30s. Or simply to say 60, 60 is cancelled, answer is 30. 30. So what you have to do? Distance is 7.5 plus 10 plus 30. So upon time, time is 15 minutes, 15 minutes, 30 minutes. Total it is 60 minutes. 60 minutes you can take it as 1 hour, right? That is equal to, these all are kilometers only, no? Because everything is in kilometer per hour. So it will be kilometer. So 30 plus 10, 40, 40 plus 7.5, it is 47.5 kilometer upon 1 hour. So answer, yes, AVG is equal to 47.5 kilometer per hour. Like this you should solve. Then plan this fifth one. You can pause the video, solve, this is the answer, solve it, and you can come back for the solution. So the solution for this is, a body travels distance S1 with velocity V1, S2 with V2. In the same direction, calculate average velocity. Okay. So body is traveling distance S1 with velocity V1, and it is traveling distance S2 with V2. Average velocity we have to find. Now average velocity, or SAVG or VAVG, whatever it may be, it is total distance traveled by the body in total time taken. What is total distance? T1 plus D2. What is time taken? T1 plus T2. Now SAVG or VAVG is equal to, what is D1 distance? S1 it has traveled, S1 plus, what is D2 distance? S2. S1 plus S2. Straight away you have taken the numerator upon what is total time? T1. Here they didn't talk about time. Now we have to extract time from the basic formula, that is speed is equal to distance by time. From this, time is equal to distance by speed. Now what is the first condition? Distance. It is S1 by what is the first condition? Time. Velocity, that is V1. So we'll get T1 as, that is T1 as S1 by v1 plus again same t2 as second distance, that is s2, second velocity is v2. So t2 we can substitute as s2 by v2. Now we have to solve this denominator. So if you solve, we are going to get, so numerator will be as usual s1 plus s2 upon, now LCM for this v1 and v2 is v1 v2. Now numerator it becomes s1 into v2 plus s2 into v1. Now this you can reciprocal. If you reciprocal, straight away what happens? Yes, AVG is equal to this denominator, it goes to here, numerator, that is v1 v2 multiplied with s1 plus s2 with this upon this. Straight away you can write s1 v2 plus s2 v1. So this is the solution for this. And last question of this video. Try to solve this last question and come back so that we'll see. And this question is also so easy to solve. Answer is 55 km per hour. Did you get it or not? You can cross verify it with the solution. So how to solve this sixth question? A car travels along a straight line for first half time with the speed 50 km per hour. So first half time, this first half time, that is if you take total time as t, this is t by 2 with speed 50 kmph. And second half of the time, t by 2 with speed 60 kmph. Now what is the average speed? We know formula average speed. Yes, AVG is equal to total distance upon total time. Now what is the total distance? d1 plus d2. This is a very basic formula we are using for every problem. Time is t1 plus t2. Now we know time t1, that is t by 2 plus t by 2. Now we don't know distance. How to extract distance from the formula? Speed is equal to distance by time. Distance is equal to speed into time. For the first condition, d1 is equal to s1 t1. For second condition, d2 is equal to s2 multiplied with t2. Now d1 is equal to, what is the first speed? 50 multiplied with what is time? T by 2. In second condition, speed is 60 multiplied with time is t by 2. So we can substitute it as 50t by 2 plus second distance 60t by 2. Now numerator it becomes, if we take LCM 2, it is 50t plus 60t by t by 2 plus t by 2, it is t. Now it becomes 50t plus 60t by 2t. Now what is 50 plus 60? It is 110. 110 t by 2t. T gets cancelled. 2 110. If you make it 2 5s 10, again 2 5s 10. So we'll get answer, yes, AVG is equal to 55 km per hour. So these are the numerical problems, examples and practice problems from the book SL Arora, from the concept speed, velocity, average velocity, distance and displacements. So we'll see another set of numerical problems from the same chapter, motion in a straight line, after completion of few concepts. So to cover the theory, you can check out the playlist from my YouTube channel, that is motion in a straight line. So after completion of the theory, you can come back to the numerical problems. Okay, till then, keep on practicing. Share this video to your friends so that you can learn together, grow together. Thank you. Have a nice day.